So today we have our Leetcode daily question, maximum number of moves in a grid. So we will be given a grid of which is a 2D matrix and it will contain some numbers. We have to move from left to right of that grid and we have to make sure that the step in which we are moving, the next element should be greater than the previous one. So let me just you can go through the question. I will just quickly solve or give this example in a textbook. So suppose this is a grid given to us. It is the number and these are its locations, row and column count. So one way is that we can move from a element, we can move forward, upward and this downward. From 5 we can move upward, forward and downward. The condition is that the next element should be greater than the previous element. 2 can move to this 4, to this 4 also. 5 cannot move to any of this because the next element is smaller. 3 can move to 4, 4 and 9 because they are larger than 3. But this 10 cannot move to 9 or 4 because it is smaller. So at the end we have to find the maximum number of moves that we can perform or the maximum number of the steps we have to take. From 2, then we will go to 4, then we will go to say 9 and then to 3. So 1, 2, 3, 3 steps are taken. Similarly from 3 there can be 4, then 13, then 15. Again there will be 3 jumps, so 3 steps were possible. So the maximum number of moves in this grid will be 3. So how to solve this question is, we have to iterate, like it is a simple DFS call. We will start from every starting node, we will have a loop for this, and from here we will try to traverse these next columns, and while traversing them we have to make sure that we are doing the next DFS within the grid only. For that we can add on conditions. So the solution would look like this. So this would be the starting point. We have calculated the row count and the column count and we have our answer is equals to 0. We are solving, we are iterating over each row. So what over here is happening is we are going first, we are starting from this, then from this, then from this and then from this. So we are changing this I value from 0, 1, 2 and 3. We will compare this answer and we'll keep the track of the maximum step. Temp will hold the interim solution. So how this is gonna be happening is that in the recursive solution we will send I 0, which is a row, which is the current pointer, that whether the DFS call is starting from this point or this point or this point or from this point. We are sending the row to and count and the grid value over there. We are sending this to, for next iteration we are sending 5 and then for another iteration 3 and at last we are sending 10. This is our base condition. We are checking that whether we have not crossed this grid using this J column counter. If J has reached over this, then we will return 0. Then we have these 3 variables. Right up is over here, right is like this and right down is this. Now this first condition, check for right up. from over here we decrease I minus 1, and if it is greater than 0, and additional condition is that j plus 1 should always be less than c, it should never cross this grid. So it should be like we should have an like I minus 1 should be greater than 0, it should be within the array column, and the last condition is the current value should be less than the next value which we are intended to jump, we are planning to jump. So from suppose 2, this condition would, first condition would become false because I minus 1 is minus 1, so we cannot jump over here. Then the next condition starts that I right jump, so I should be greater than 0 and j plus 1 or the right jump should be less than the column count, so it is so. And the next value grid I and j plus 1 is also greater than the current value. Current value is 2, next value is 4. So yes, we will do 1 plus and we will come over here. Then we will again iterate. So when we enter this recursive call, so again this whole recursive call will be called, and this from this 4 we cannot jump to 3 because it is smaller than 4. So then we will jump to 9. So this 9 condition will be satisfied by this condition. Then again from 9 this solution will again start, and from 9 this I minus 1 5 would be not applicable because it's smaller, 3 is also smaller, and 11 is bigger, so we can go over here, and whenever we are moving we will increase the counter plus 1 and plus 1, so the answer will be 3, and at last this would jump forward, so we will return 0. So now at last we will compare who is giving us the maximum value. The right up, right from here it will be all 0 0 0. So at last we will trace back and 3 will be returned. So these are the 3 conditions, you can go through them, and it is a very simple solution, and this would give a TLE solution because it is a recursive call. We can also memorize this code. To memorize this code, what we have to do is we will declare a vector of int value dp of size row and vector of int row and column with initial value -1, and we will pass this dp vector over here, like we can pass it in the function, and in the iteration we will check that if our dp I comma j is not equals to -1, so we will return that value at dp I comma j. Else what we will do is we will just add an additional condition that dpij is equals to this max answer. This would make the answer acceptable in Leetcode.